So we are going to start with our first numerical, chapter 1, unit 4, electric current. So the equivalence resistance of the circuit is, so there are the circuit there are 8, 9 and X resistance and 3 and 5 ohm resistance. So R equivalent is given as 6 ohm. So we have to find X. We have to find the value of the X. So suppose current I is coming in the circuit, so it will get divided into I1 and I2. Current will pass through all the three resistances, and I2 current will pass through all these two resistances. It means that the three resistance 8, 9 and X are in series. Similarly 3 and 5 are in series because same current is flowing, and because 8, 9 and X, the equivalent resistance, we will get two equivalent resistance. We will get two equivalent resistances. This will be the parallel combination of 8, 9 and X, and this is the parallel series combination of 3 and 5 and series combination of 8, 9 and X. So series combination of 8, 9 and X is 9 plus 8 is 17. So this is 17 plus X. This will be equal to 17 plus X, and this will be 5 plus 3, 8. This will be equal to 8. Now these two are in parallel because here current I1 comes and here current I2 is coming. Since these two are in parallel, therefore R equivalent will be equal to 1 by R equivalent will be 1 by 17 plus X plus 1 by 8, and that is, and R equivalent is given as 6 ohm. So this is equal to 6 ohm. It means 1 by R equivalent is equal to, we'll take LCM, 17 plus X into 8 and 8 plus 17 plus X is equal to 1 by 6. So 1 by R equivalent. So R equivalent comes out to be R equivalent comes out to be the reciprocal. So R equivalent is 6 is equal to 17 plus X into 8 divided by 17 plus 8 plus X. So 17 plus 8 plus X. So we'll solve this for the value of X. We have 17 into 8 is equal to 136 plus 8X divided by, we have 17 plus 8 is equal to, we'll get 25. 17 plus 8 is 25, and then we have plus X. We have plus X is equal to 6. So we'll solve it further. When we'll solve, we'll get 136 plus 8X is equal to 25 into 25 plus X into 6. So this is equal to, so 25 into 4 is 100 and 25 into 6 is 150. 150 plus 6X. So 8X will get 8X and minus 6X is equal to 150 minus 136. So 2X is equal to 150 minus 136 is equal to 14. So 2X is equal to 14. 2X is 14 and X comes out to be 14 by 2 is equal to 7 ohm. So X comes out to be, unknown resistance is 7 ohm. This was our first numerical. Now we'll move to the second numerical. Now we'll move to second numerical. So second numerical, 4 resistances for 0.5, 1.5, 4 and 6 respectively are connected in series across a battery of EMF 6 volt, battery of EMF 6 volt, and in negligible internal resistance. Calculate the current drawn from the battery. So four resistances are in series. So we have four resistances in series. The four resistances are 0.5 ohm, then we have 1.5 ohm, then we have 4 ohm, and we have 6 ohm. And these are connected in series across a battery of 6 volt. So in series across a battery, and EMF of the battery is 6 volt and internal resistance is negligible. Calculate the current drawn from the battery. So first we have to calculate current. So current is equal to, for find current we have to find the equivalent resistance. Because V upon R is equal to I. V is equal to IR and V upon R is equal to I. So we'll get V upon R equivalent. So it is equal to, V is given as 6 upon R equivalent equal to I. Now R equivalent is equal to, in series, because all are in series, we have R equivalent is 0.5 plus 1.5 plus 4 plus 6. So 6 plus 4 10 plus 1 11 and 12. It is 12. Therefore R equivalent is 12 ohm, and therefore current is 6 upon 12 is equal to 1 upon 2 is equal to 0.5 ampere. So current drawn is 0.5 ampere. Next we have to find the potential drop across each resistance. So potential drop across each resistance. We have to find the potential drop across each resistance. So let the resistance be R1, R2, R3 and R4. We have potential drop here as V1, V2, V3 and V4. So V is equal to I into R. So because I is same, all are in series, and I is same, I. Current is equal to, we have find in first step, current is equal to 1 by 2 ampere or 0.5 ampere. So V1 is equal to I into R1. So it is equal to 1 by 2 into R1 is 0.5. 1 by 2 into 0.5 ampere. So this comes out to be 0.0. It comes out to be 0.25. 0.25 ampere. Similarly, V2 is equal to I into R2 is equal to 1 by 2 into 1.5. So this comes out to be 0.75 ampere. Similarly, V3 is equal to I into R3 is equal to 1 by 2 into 4 is equal to 4. So this is potential, volt. Potential in volt. So I into R3 is equal to 1 by 2 into 4 is 2 volt. Similarly, V4 is equal to I into R4 is equal to 1 by 2 into R4 is 6. We get 3 volt. So all resistances are, these are all the potential drops. Now we'll move to the next question. Move to the next question. Next question is question number 3. Question number 3. A cell of EMF 6 volt. Cell of EMF 1.8 volt is connected to an external resistance of 2 ohm. Find the potential difference across the resistance. Calculate the internal resistance of the cell. So EMF Cell of EMF 1.8 volt. So this is a cell of EMF. EMF is 1.8 volt and it is connected in series with an external resistance of 2 ohm. So it has an internal resistance also. Let internal resistance is small r. Small r with the internal resistance and external resistance is, the external resistance is 2 ohm. External resistance is 2 ohm. The potential difference across the resistance being 1.6 ohm. So 1.6 volt. So the potential difference here is 1.6 volt. Potential difference across 2 ohm resistances. Potential difference across 2 ohm resistances 1.6 ohm. Therefore current is, we have V is equal to I into R. So V is given as 1.6, I we have to find, and R is 2 ohm. We get 1.6 divided by 2 is equal to I. So I will get 0.8 ampere. So it is equal to 0.8 ampere. So current from the battery is 0.8 ampere. We have to find the internal resistance. Now, potential drop across internal resistance R. Potential drop across internal resistance is EMF minus the terminal voltage. So EMF is 1.8 volt minus terminal voltage is resistance in outside circuit is potential drop across outside circuit is 1.6. We get 0.2 volt. So 0.2 volt is the potential difference across the internal resistance. Therefore, across internal resistance again we have V is equal to I into R. So V is 0.2. I we have find in the first part, I is equal to 0.8 and R is the internal resistance. Therefore, from here we get R internal resistance is equal to 0.2 divided by 0.8 is equal to 2 divided by 8 is equal to 2 divided by 8, and it comes out to be 1 by 4 is equal to 0.25 ohm. So 0.25 is the internal resistance. Internal resistance of the cell comes out to be 0.5 ohm. Now we will move to the next question. So now we will do the next question. Next question is question number 5. In the figure shown, the ammeter reading is 0.3. So there is a circuit given. So fourth question is, it is question number 4. There is a circuit given. So there is a cell, there is a battery of EMF 6 volt. Then we have a ammeter. The reading of the ammeter is 0.3 ampere. Then we have a circuit in which two resistances are in parallel. So two resistances are resistance R and 60 ohm resistance. So this is the circuit given. Calculate the total resistance of the circuit. Calculate total resistance of the circuit. value of R and current flowing through the R. So total current, we have to find total resistance of circuit. So total resistance of circuit is equal to, we have V is equal to I into R, V upon I is equal to R total. So total potential upon total current. So total potential is 6 volt battery and total current is current in the ammeter, which is 0.3 ampere. So total resistance of the circuit is 6 divided by 60 divided by 3 is equal to 20 ohm. So 20 ohm is the total resistance in the circuit. Second part, we have to find the resistance R. We have to find R. So R and 60 are in parallel. Therefore, we have R equivalent is equal to 1 by R equivalent is equal to 1 by R plus 1 by 60 is equal to 60 plus R divided by 60 R. This is 1 by R equivalent. Therefore, and this is given as 1 by 20 because R equivalent is 20 we have find. Next R equivalent comes out to be 60 R divided by 60 plus R, which is equal to 20. So from here we have so and 23 is 60. So 3R is equal to 60 plus R. So 3R minus R is equal to 60. 2R is 60 and R comes out to be 30 ohms. So the R value of R is 30 ohms. So this resistance R is equal to 30 ohms. This resistance R is 30 ohms. And current we have to find. Third we have to find current through R is equal to 30 ohm. So 30 ohm resistance से करंट कितना पास हो रहा है? So यहाँ से करंट कितना आया? 0.3 एम्पियर. यहाँ से करंट कितना है? 0.3 एम्पियर. और so we have to find the current passing through the resistance R. So we have V is equal to IR. So V upon R is equal to I. V upon R is equal to I. So V is equal to, because R and 60 ohm are in parallel, therefore same potential drop across each resistance. And that potential drop is because the end A and B are directly connected with the battery of 6 volt. They are directly connected with battery of 6 volt. Therefore, potential difference here is also 6 volt. So 6 divided by R is 30 is equal to I. So it is equal to 6 by 30 is equal to 1 by 5. So it is equal to 1 by 5 amperes. 1 by 5 ampere is the current and 1 by 5 ampere is 0.2 is equal to 0.2 ampere. 0.2 ampere